Hello, Professor. My name is Hardik Kumar. My student ID is 101410993, and this is my presentation for Machine Learning course comp3132, assignment 1. So in this assignment, we had to basically train a model on fashion minist database and perform a few questions. So in question 1, we have what are the dimensions of train images, train labels, and test labels. So uh, these are dimensions. So train images has like 60,000 images, and which are like 28 by 28 pixels, and test images has 10,000 images which are 28 by 28 pixels again. Next question says what is the length of train labels and test labels, which we can find out using the length function. So because train label has 60,000 images, the length of it is 60,000, and the same for test labels because it has 10,000 images, its length is 10,000. Next it says please show some of the train and test labels, which is this, which just mean these categories of clothing from 0 to 9. Next it says please show the digital content of image index at 5. Next question says please show the image at index 5, which is this. Next question says please what is the label for index 5 in the train label, and looking up in the pub list, what does it mean? So its label is 2, which means it's a pullover. Next question, it says please show digital content of the image at index 500 in the testing dataset, which is this. And next it says please plot that image at index 500. This is that image. And next question asks what is the label for the index 500 in the test label, and looking up in the pub list, what does it mean? So its label is 2, which means again it's a pullover. Next question, it says please import models and layers from the Keras library, which we have already done at the top of the file over here. Next question, which is question number 11, it says please define a sequential model and call it my network, which we have done here. Sequential model is just a model which stacks images on top of each other. Next question, it says reshape the images from 28 to 28 one column with 784 neurons. So we have done that using the layers.flatten function. It basically converts this 2D array into a 1D array of 784. Next this is also please normalize the image by dividing the image by 255. So what this basically does is it scales the pixel values of the images from 0 to 1. Next question says add one hidden layer that has 512 neurons using the Relu activation function, which we have done here. Next question says add another hidden layer that has 128 neurons using the Relu activation function, which we have again done. And the dense layer basically creates a fully connected layer, and Relu is used to introduce non-linearity to the model. Question 16 says add the last layer as a 10 neuron dense layer that uses softmax as the activation function. And it says why do we use softmax for the last layer? So the softmax function is used for multi-class classification problems because we have like multiple classes of things like dress, pullover, etc., etc. In this dataset, instead of the just single category, that is digits in the minutes dataset, so that's why we're using softmax here, and it converts the raw output into a probability distribution over the 10 classes that we have, and ensures that the sum of the output values is 1. so that when we sum the output values, it points to one single category that it says that, hey, this image belongs to this particular category. So next question, which it says that use the following two settings for the compiler and run them separately and see what the differences are. So I've already ran them and I found out that option A has the Adam optimizer, which adapts the learning rate during the training, whereas this option B has RMS prop, which adjusts the learning rate based on recent gradients. And usually people say that Adam tends to perform better in most cases, but we have to test it out to find it. And in terms of loss function, the first one has sparse categorical cross entropy, which works when we have labels in the form of integers, which we have here. And option B has categorical cross entropy, which is used when we have one hot encoded labels, which we don't have. So we're going to use this one. That's what I use after to basically train my model in 10 epochs. So it says after compilation, please try to find the pattern using the bit command. Set the number of epochs to 10. This takes a lot of time, so I've already pre-ran this. Next question says, how do you compare the fashion minutes with what we have learned in the class during minutes? So I basically found out that fashion minutes renders our model with less accuracy as compared to the minutes dataset because fashion minutes has different category of clothing which itself has different textures and shapes which are difficult to train on as opposed to the minist dataset which has just digits which are more difficult, which are like easier to train on. So our model has higher accuracy in the minist dataset as opposed to the fashion minist. Next question says, what can we infer from the differences in the accuracy? So just as I just said, the fashion minist dataset has images of clothing and different types of clothing at that, and which has different textures and shapes, which makes our model less accurate as compared to the minist dataset, which has just digits, which are easier to train on. So that's what makes it less accurate. Next question says we use the evaluate function from the Keras library to calculate the achieved accuracy, which I've done here. And the test accuracy is this, and the loss uh, percentage is this. So it says, do we have overfitting? So yes, we do have overfitting in this because the train accuracy is 91%, which is more than the testing accuracy, which means that our model does not do well with the data it hasn't seen. So yeah, we do have overfitting. So thank you for that. This was my presentation for assignment 1.